Hey, how are you doing? Today we are going to discuss a problem on how to find outliers. Outliers are numbers which are far away from the rest. So here is the problem. Okay. The summary statistics for the number of inches of snow in Denver for 116 years is listed below. N, total number of sample, or in the population 116, mean is 10.443, median is 10.364, standard deviation is 1.541, minimum is 6.213, maximum is 14.578, Q1 is 8.746 first quartile, that is the 25th percentile. That means 25% of the numbers are below 8.746, and Q3 or the third quartile, that is 75% of the numbers are below 12.379. Are there any outlier in this data set? So any outliers in this data set? That is the question. Okay. So first we will find the interquartile range. Interquartile range, which is IQR. It is the range of the middle 50% of the data. That is how widely the middle 50% of the data are spread out. So it is given by Q3 minus Q1. And that in our case is 12.379. Q3 minus Q1 is 8.746. Okay, and that is equal to, the interquartile range is equal to 3.2965. So IQR is equal to 3.2965. Okay, now as the standard procedures calls for, we will find out 1.5 times IQR, or in this case 1.5 multiplied by 3.2965, and that is equal to 5.4495. So let me create some space. So first we will calculate the upper outlier boundary. Is equal to Q3 plus 1.5 times IQR. So my Q3 is 12.379 plus 1.5 IQR is 5.4495. So upper outlier boundary is equal to 17.8285. Okay. Let me make sure I've done my calculations correctly. So it's 12.379 plus 1.5 times interquartile range is 3.2965, and this is equal to 17. Not 8. So let me make sure I've done this information correctly. So 1.5 multiplied by, so let me make sure my calculations are right. Interquartile range is 12.379 minus 8.745, and that is equal to 3. Oh, I made a mistake. 12.379 minus 8. So 12.379 minus 8.745 is equal to 3. This is wrong, so let me correct that. So my interquartile range is, this is correct. Incorrect, this had been incorrect. So this is 3.634. So you multiply 3.634 by, so you're going to multiply 3.634 times 1.5, and that will be equal to, okay, so it is 3.634 is the interquartile range. So let me correct this also. So this is again 12.3. Okay, so 12.379 minus 8.746 is 3.633. So 3.633. So IQR is 3.633. And you multiply that by 1.5. 3.633 times 1.5, and that is equal to 5.4495. Okay, so your upper outlier boundary is 12.379 plus 5.4495, which is 17.8285. Let me highlight that, 17.825, and compare that with the maximum. So if I move up a little bit, you will see the maximum is 14.578. So given max data point is 14.578. Hence, since the maximum data point is less than the upper outlier boundary, no outlier on the right, no outlier on the right. Let's do the same calculation on the, or similar calculation on the left side. So let's be, so we note the Q1 is 8.746. So lower outlier boundary, outlier. So lower outlier boundary is Q1 minus 1.5 times IQR, which is equal to, what is my Q1? So I'll take a look again. My Q1 is 8.746. So it is 8.746 minus 1.5 times IQR is 5.4495, which is equal to, so you have 8.746 minus 5.4495, and that is equal to 3.2965. Given minimum data point in the table, this is minimum data. So let me erase this minimum data point in the table. We will again take a look, is equal to, so if you move this down, you'll see minimum is 6.213, is 6.213. Since the minimum is data point is greater, is actually minimum data point is greater, minimum is 6.2213, okay, is greater than the lower outlier boundary. Some people call it lower outlier fence. There is no outlier on the left, no outlier on the left. Bottom line, so if I create some space, move this a little bit up, there is no, this is the critical thing, no outlier in this data set. And just to remind you, the maximum data point is lower than the upper outlier boundary, and minimum data point is above the lower outlier boundary. Hence, no outlier on this in this data set. Okay, no outlier in this data set. Before I stop, I want to give you an important tip about this. The important tip I want to give you is that first you find out the interquartile range, which is Q3 minus Q1. Then you multiply that by 1.5 to establish, we need 1.5 times IQR to establish the upper outlier boundary, which is Q3 plus 1.5 IQR. And similarly, the lower outlier boundary is Q1 minus 1.5 times IQR. Now, in our case, our maximum data point as given by Max in this problem is less than the upper outlier boundary, and the minimum data point is above the lower outlier boundary. Therefore, there is no outlier in this data set. So calculate the interquartile range, which is Q3 minus Q1 multiplied by 1.5. Then to the upper quartile or Q3, you add 1.5 times IQR to establish the upper outlier boundary. Any number above the upper outlier boundary would have been an outlier. Similarly, Q1 minus 1.5 times IQR establishes the lower outlier boundary. Any number less than that lower outlier boundary would have been an outlier. Okay, so I'll stop here today. If you like my video, give me a thumbs up. I really appreciate that. Also, please write something, whether you like this video, whether you want more of this type of video, please let me know. This motivates me extremely if you give me thumbs up and if you write a comment, okay? And if you like this video, share with your friends. You and your friends, please subscribe to my channel, Math Science Topia, by hitting the red subscribe button at the bottom right corner. And let YouTube know that they will notify you every time I upload a new video. So I'll stop here today. Do not forget to watch me tomorrow when I'll be back with another important problem, important solution. Thanks for watching. Have a nice day. Take care. See you tomorrow.